For problem number 17, a student makes a simple AC generator by using a simple square wire loop, 10 centimeters on each side. The wire loop is then rotated at a frequency of 60 hertz. Okay, and a magnetic field. I think there's a typo here. This should say a magnetic field of 0.015 Tesla. What's the maximum EMF output? Okay, and so there's like a magnetic field, and then what I'll try to draw it as best I can, the way it is in the book. And so then you have your magnetic field. Let me draw this. And then the magnetic field is going through north and south. Okay, and it's a simple wire loop at 10 centimeters on the side, which is really 0.1 meters of the square. Is it square? Generate by simple square, yep. And a frequency of 60 hertz. So the first thing I want to know is, what is EMF? So the maximum EMF, electromotive force, can be calculated by taking the number of turns times the cross-sectional area times the magnitude of the magnetic field times omega. Now, omega, as you may recall, is something that we call an angular frequency. Now, frequency is how long. It's like the frequency is inversely proportional to the wavelength of what we call an electromagnetic wave, and it's how long does something take to complete one cycle. Now, when we talk about circular motion, we can measure that frequency, how long does it take to complete one cycle, based on one revolution. So we would call that an angular frequency. But then if we graph this as a sinusoidal wave, the cycle is going up one peak and down through a trough and starting off where we end, or one wavelength. And so they didn't give us an angular frequency. They gave us more, this is a better word might be like a linear frequency, but it's I don't think that's correct either. But anyways, the relationship between the two is that 2 pi f is equal to omega. Okay? So it looks like a W, and you might say, Mr. Adams, why do you keep calling that W omega? Because it's the Greek letter omega that looks a lot like the W. Okay? And it's always associated with angular frequency. So I need to change my equation, I guess is what I'm saying, to this. And so one way you can think about it is the 2 pi, that's 1, what is 2 times pi times something else gives you the circumference. So that's the relationship, right? So when we're measuring one full cycle, in other words, as this thing rotates one full revolution, that will be in the time that it takes to do, that's the angular frequency, right? But the formula calls for a variation of that frequency, which is inversely proportional to the wavelength of the electromagnetic wave. So we're gonna switch that out, right? So now what does that mean? The electromotive force is how many turns do we have? How many loops? Only one, right? It says a simple square wire loop, A, meaning 1. The area of this square, well, it's just 0.10 times 0.10, or 0.10 meters squared. The strength of the magnetic field is this right here, 0.015 Teslas. And then all that is 2 times pi times 60, was it just hertz? And hertz is the correct unit for frequency. So all of our units line up, so we don't have to do any conversions. And I just need to plug this in to a calculator, and I'll get an answer. So if you multiply that all the way through, you get 0.057 volts. Does that make sense? Now that's part A. Now the question for part B is, how many loops would you need? So it says if she wanted to make a maximum EMF output 10 times larger by adding loops, how many should she use total? So how many loops would she need?
She wants to make it 10 times larger.
Yeah. So in other words, she wanted to increase this
To 0.5.
Yeah, to 0.5.
You need 10 loops.
Yeah, 10 loops. Because this right here represents the loops.
Yeah.
So this is proportional to the number of loops I have. So if I want to increase or this is what we call in math a scalar multiplier of all this other stuff, right? So I could calculate this magnitude because it's just 1. So this whole thing times 10. So I guess what we're saying is for part B, this is part A, for part B we would need 10 loops total.